Okay, Northern Oklahoma College, Math 1513. I'm doing Chapter 1 from the College Algebra book, 1.1. This is an example to show you how to do 23. Now, some background. We need to know what contradiction and identity and conditional equations mean, okay? A contradiction is something that is never true, all right? For example, if you work and work and work on your algebra problem, and you come up with something like x plus 1 equals x plus 4. Well, if you think about it, there isn't a number in the whole world that'll work there. You can't put anything in for x that will make that equation true. If you continue to solve this, you would try to get rid of the x from one side, but actually it would eliminate the x from both sides, and you're going to come up with something crazy like 1 equals 4, all right? If you continue solving that all the way to the bitter end, you'll come up with something that is never true. 1 is never equal to 4, and so this would be a contradiction. This would be an equation that has no solution. All right, move over to identity. Identity, you're working along on your algebra, and you solve everything, and you come up with something maybe that looks like this. X plus 1 equals x plus 1. Maybe you've done all that solving, and you come up with something like that. Well, think about it. I can put any number in here for x. All right, let's say I put in a 2. If I put a 2 there and a 2 there, 2 plus 1 is 3 on the left, and 2 plus 1 is 3 on the right. It works for all numbers. It's always true. Now, if you had continued solving this, here's what you would have seen. You would have subtracted x. Actually, both your x's would have gone away, and you'd come up with something like 1 equals 1. Well, 1 equals 1 is always true. So when you come up with something like that, when you come up with the same thing on both sides, what you're dealing with is called an identity. And any number will work. Any number works. Any number works. Okay? For a contradiction, basically there's no solution. No number works. All right? Conditional equations are what you're used to seeing. You're used to seeing an equation that has a certain solution. So conditional equations are true, but only for a certain number. You can't put just any number in. For example, you're solving this simple equation here. Whoops, that's an ugly equal sign. X plus 1 equals 3. You're going to try and isolate the x by subtracting 1 from both sides. Your 1's cancel. X equals 2. This is called a conditional equation. It is true, but only for 2. So true, but only for 2. All right? It's true for only a certain number. All right? I should have put an apostrophe S there. Certain number or number. Sometimes you'll get a couple answers. All right, let's try and figure out what this is. Conditional or an identity or a contradiction. I'm looking at this, and the first thing I see is those fractions. We just learned how to take care of those fractions. I have to figure out what the LCM is. Remember, the lowest common multiple. So I look at my denominators. I have a denominator of 3 and another denominator of 3. Well, that's easy. What do 3 and 3 both go into? Well, they'll go into 3, 6, 9, etc. I want to pick the lowest one, 3. So what we're going to do to get rid of these fractions is multiply everything, this whole expression, by 3. Okay, now you guys remember how to do this. I just rewrote the expression. I left a little space in front of each one, and I'm going to multiply them by 3. Now this one in front here, that's not a fraction, so I'm going to leave my 3 as a whole number, times 3. This one right here, the 1/3, that's a fraction, so I'm going to change my 3 to a fraction, 3 over 1. And this one right here, it might help if you put parentheses over this. If that's a fraction, I'm going to change my 3 to a fraction, 3 over 1. So let's multiply this out. 3 times 2x is 6x plus, all right? Now we multiply this fraction, we get 3 on top because 3 times 1 is 3. And on bottom we have 1 times 3 is 3. We'll simplify that to 1 here on the next step. Over here we have on top 3 times our 6x plus 1. And on bottom we have 1 times 3 is 3. Okay, let's simplify a little further. 6x, we'll wait on him for a minute. Let's just bring him down. Plus 3 over 3, that's 1. 3 divided by 3 is 1. And if you look over here, again we have a 3 over 3. 3 divided by 3 is still 1, so I could write 1 parentheses 6x plus 1. But you know what? Multiplying anything times 1 doesn't change it, so I'm going to leave that 1 off. Alright, so I'm just going to leave this as 6x plus 1, and I'm going to say that the 3's cancel, and left is 6x plus 1. Alright, look at what we have. 6x plus 1 on the left, and 6x plus 1 on the right. Alright, you should be able to figure out what this is already. And you could stop right here in the problem and tell me what it is, and I would say, okay, you've shown enough work, you know what's going on. But if you didn't recognize it yet, and you continued with the problem, you would try to subtract 6x from both sides. Your x's would accidentally cancel out, and you'd end up with 1 equals 1. Now, by now, for sure, you should see that this is an identity. Your left side and right side are equal to each other. That means it's an identity. So you're going to write identity. And then if I ask you what that means, it means that back in the original problem, back up top here, I could have put any number in for x, and it would have worked. Any number at all. All numbers work. All right, let's try this one and see what it turns out to be. This is an example for problem number 25. Remember, I have a set of brackets. Just think of that as an extra set of parentheses. And inside them, I have a set of parentheses. So we're going to work from the inside out. And we're going to follow along with your order of operations. So parentheses, I'm looking first to see if I can add the x and the 3. No, they're not like terms. One's a variable, one's a number. So no parentheses, nothing, there's no exponents, nothing being raised to a power. I look for multiplication, so I'm going to multiply the 5 times everything in the parentheses. Negative 5 times x. That's 5x, and it's negative because the positive times the negative is a negative. 5 times 3 is 15. Negative times negative is positive, so it's plus. And that's all I'm going to do for now. Bring everything else down. Bring down the 2x. Close your brackets. Put your equal sign here in your 6. Always a good idea to put your fence over there to keep the equal signs all lined up. All right, I got rid of the inside parentheses. And actually, I have a little more here I can do. I can do a little addition and subtraction inside. So I'm looking inside these brackets. I see an x term, and a whole number. I can add those x terms together. 2x minus 5x gives us a negative 3x. My plus 15 comes down. I'm going to go ahead and leave the brackets there for now because I still have this times 4 out front that I haven't done yet. Bring down your equals 6. All right, did our addition and subtraction. We're still messing with the parentheses though, so let's go ahead and take care of that 4 now. Let's multiply everything by 4. 4 times 3x is 12x, and a positive times a negative is a negative, so minus 12x. 4 times 15 is 60, and a positive times a positive is a positive, so plus 60 equals 6. We continue to solve. Remember to get rid of what's furthest from the x, so get rid of plus 60 by minus 60. Sixties cancel. Negative 12x equals negative 54. To get rid of x, remember this is times. This isn't x minus 12. It's x times negative 12. So to get rid of times a number, we divide by that number. Don't forget to divide by the negative as well. You want to get rid of the 12 and the negative at the same time. So divide by negative 12. Remember to do it on both sides. Cancels your negative 12s. Your x is alone. And we have a negative divided by a negative. That's going to be a positive 54 over 12, which reduces to 9 over 2. Remember I said it's fine to leave it as an improper fraction as long as you simplify it, and your calculator will help you simplify it. So x equals 9 over 2, but to answer the question, what kind of a equation is it? It's a conditional equation. Why? Because it is true, but only for one value. It's only true when x equals 9 over 2. Okay, here's example, a problem for example 27. Still trying to figure out this conditional equation, identities, and contradictions. Now what we have here is a fraction set equal to another fraction. We haven't actually seen this before in the homework problems I worked before. Now we could do it the hard way and find the lowest common multiple of 5 and 1 and multiply everything by that 5, and it would take quite a while, as you saw in some of those other problems. But there's actually a trick. When you have a fraction equal to a fraction, that's called a proportion. And proportions are real easy to solve if you just cross multiply. That's the trick. That's the secret. Solve proportions quickly by cross multiplying. Okay, so I am going to put parentheses around these. It'll make more sense. And I'm going to cross multiply. I'm going to multiply the 5 times that x plus 10. So 5, let's go back to black here. 5 times x plus 10, and it's going to be equal to the other cross multiplier, the 1 times the 5x plus 10. So it's going to be equal to the other cross multiplication. All right, what do? We got to get rid of the parentheses. How do we do it? Well, we look inside. That's an x, that's a number. I can't add them together. That's an x, that's a number. They're not like terms. I can't add them together. So my only choice is to multiply to get rid of that parentheses. So I'm going to multiply everything in that parentheses by 5, everything in this parentheses by 1. 5 times x is 5x. 5 times 10 is 50, and it's positive times positive, so it's plus. Equals 1 times 5x is 5x, positive times positive, so it's plus, but I won't write it in front of it. 10 times 1 is 10, positive times positive is positive, so we write plus. All right, you can probably recognize it from this point. There's not going to be any number that'll work in that because my 5x's match up, but look at this, my 50 and my 10, that's what throws a wrench in everything. Since one side's adding 50 and one side's adding 10, there's no possible number that you can put in there that's going to work. Now let's say you didn't recognize that right away and you continued trying to solve this. Here's what would happen. You would try to eliminate an x, and in the process you would accidentally eliminate both x's, and you'd have 50 equals 10. Well, of course, 50 does not equal 10. All right? So what that means is there is no solution. In the book, they call this a contradiction. Whoops. No solution. The book calls it a contradiction. Okay, I prefer no solution.